It is not an asteroid. That is the verdict. Not a guess, not a theory, not a headline built for clicks. A verdict handed down by the most powerful telescope humanity has ever built, after staring directly into the heart of an object that should not exist inside our solar system at all. For months, 3I/Atlas was treated like a mystery too big to solve. A smudge of light racing past the sun at nearly 40 miles every second, trailing questions instead of answers. Every week brought a new theory. Every new image reopened the debate. Was it a rock, a relic, a runaway fragment of some shattered world from another star? Now James Webb has spoken, and the answer is stranger than the question ever was. Think about what it actually takes to settle a question like this. Start with the numbers, because the numbers alone should stop you in your tracks. 3I/Atlas is moving through space at a velocity so extreme that the sun's gravity cannot hold it. Not slow it down permanently, not bend it into an orbit. This trajectory is hyperbolic, an open curve, a one-way ticket. It came from outside our solar system, it swung past the sun once, and it is already leaving, never to return. At its fastest, near closest approach, it was moving at over 68 kilometers per second. Even out at the edge of the solar system, stripped of the sun's pull, it will still be cruising at close to 58 kilometers per second forever. No planet, no star, nothing in our solar system could ever hope to catch it. This is only the third time in recorded history that astronomers have caught an interstellar object doing this. The first was Oumuamua in 2017, a cigar-shaped enigma that tumbled through and vanished before we could study it properly. Gone before most of the world's telescopes even knew to look. The second was Borisov in 2019, a comet that behaved a little more like home, giving off familiar gases in familiar ratios, almost reassuring in how ordinary it seemed. 3I/Atlas is the third, and it may be the one that finally gives us real answers, because unlike the other two, we caught this one early. Astronomers traced its path back through archived images all the way to May of 2025, weeks before anyone officially noticed it, and they had Webb ready and waiting when it needed to matter most. Consider the improbability of that timing. This object spent 10 billion years crossing the galaxy in near-total darkness, and it happened to cross our solar system during the exact decades when humanity possesses telescopes capable of reading its chemistry. 100 years earlier, it would have passed by as nothing more than a faint smudge on a photographic plate, unexplained and forgotten. 100 years from now, if another one comes, we may have even better instruments waiting. But for this one, right now, Webb was exactly what was needed, exactly when it was needed. Now here's where it gets strange. When comets in our own solar system heat up near the sun, they release gas in a fairly predictable ratio, mostly water vapor, with smaller amounts of carbon dioxide and carbon monoxide mixed in. Water dominates. That's the rule, built from every comet we've ever measured, from Halley to Hale-Bopp to the icy wanderers of the Kuiper Belt. 3I/Atlas breaks the rule completely. Webb's spectrometer clocked the comet's outgassing and found that carbon dioxide made up the overwhelming majority of what was pouring off its surface, somewhere around 87% of the total mass loss, while water trailed far behind at only a few percent. Carbon monoxide picked up almost all the rest. In other words, this comet runs on a completely different fuel mixture than anything native to our neighborhood. It's as if you pulled a car engine apart expecting gasoline and found it running on something you'd never seen before. And then Webb found something even more unexpected buried inside that same glowing coma: methane. Plain, simple methane, the same molecule that powers stoves on Earth and drifts in the atmospheres of gas giants, detected drifting off the surface of an object that has been in the deep freeze of interstellar space for longer than our entire solar system has existed. Methane is fragile. It breaks down fast under sunlight and cosmic radiation. Finding it intact, still venting off this ancient wanderer after a 10 billion year journey, tells scientists that whatever formed 3I/Atlas locked that methane away somewhere so cold, so shielded, so untouched, that it survived a trip longer than the age of Earth itself. To catch methane at all, Webb had to use one of its most sensitive instruments, the MIRI spectrometer, tuned to mid-infrared wavelengths that ground-based telescopes simply cannot see through Earth's atmosphere. No observatory on the ground could have made this detection. It took a telescope parked nearly 1 million miles from Earth, cooled to almost absolute zero, sensitive enough to read the faint chemical whisper coming off an object racing away from the sun at incredible speed. This is precisely the kind of measurement Webb was built for, not just pretty pictures of distant galaxies, but forensic chemistry performed on objects too faint and too fast for anything else humanity has ever built. But the detection that really turned heads wasn't a gas at all. It was a metal, nickel. Webb's instruments picked up a clear signature of nickel vapor streaming from the comet, and normally, when astronomers find nickel around a comet, they also find iron riding right alongside it. The two metals usually travel together, baked out of similar minerals at similar temperatures. Not here. 3I/Atlas is shedding nickel with almost no trace of iron beside it. That single detail sent researchers back to their models, because it hints at an exotic chemistry, one that doesn't match the recipe books written by comets in our own backyard. Something about the environment where 3I/Atlas was built favored nickel and rejected iron, and right now nobody can fully explain why. Put all of that together, the carbon dioxide flood, the surviving methane, the iron-free nickel, and you get a chemical portrait unlike anything cataloged in the history of astronomy. This is not a comet built from solar system leftovers. This is a visitor from somewhere else entirely, carrying a recipe written under conditions we have never directly sampled before. And the strangeness doesn't stop at chemistry. Even something as basic as the size of this object turned into a puzzle. Early measurements from ground-based telescopes suggested 3I/Atlas could be small, a few hundred meters across, no bigger than a large building. But as more data came in, including detailed imaging from the Hubble Space Telescope, the estimates widened dramatically, with some models allowing for a nucleus as large as 5 or 6 kilometers across, wrapped inside a coma of gas and dust stretching over 500,000 kilometers into space. That kind of uncertainty might sound like sloppy science, but it's actually a symptom of something else entirely. This object simply doesn't behave the way our models expect a comet to behave. Its outgassing doesn't scale the way solar system comets scale. Its brightness doesn't fade the way solar system comets fade. Every attempt to pin it down with familiar rules produces a slightly different answer, because the rules themselves may not fully apply. So where did it come from? This is where Webb's data turns from strange to genuinely staggering. By analyzing the ratios of carbon to deuterium, a heavier version of hydrogen sometimes called heavy hydrogen, scientists were able to work backward and estimate when and where this object was born. The answer, somewhere between 10 and 12 billion years ago, in a cold, distant pocket of the early Milky Way, at a time when our own sun and Earth didn't even exist yet. Our solar system is about 4.5 billion years old. 3I/Atlas could be more than twice that age. Some researchers have gone so far as to say this comet may be nearly as old as the universe itself, forged when the galaxy was still young, still forming its first generations of stars, still writing the earliest chemical chapters of everything that would eventually become us. Try to sit with that for a second. Every atom boiling off the surface of 3I/Atlas right now, visible through Webb's infrared eye, has been drifting through the galaxy since before there was a sun to warm it, before there was an Earth to walk on, before there was anyone anywhere to look up and wonder. When this object first formed, the Milky Way itself looked nothing like it does today, younger, denser with gas, still assembling its earliest generations of stars. Our own sun wouldn't ignite for another 5 to 7 billion years. The building blocks of Earth were still scattered as dust, waiting for a star system that hadn't been born yet. It has crossed unimaginable stretches of empty space, survived the radiation of 100,000 centuries, drifted through regions of the galaxy no human instrument has ever directly sampled, and by pure chance, its path intersected ours for exactly one brief pass close enough for us to notice. Somewhere along that 10 billion year journey, it could have passed near 100 other stars, skimmed the edges of a dozen other planetary systems, and none of them left a lasting mark on it, until our sun warmed it just enough to make it glow, just enough to make it visible, just enough for us to catch it in the act. In a few more months, it will be gone, hurled back out into the dark, never to return, carrying its ancient secrets with it, indifferent to the fact that anyone ever noticed it at all. Naturally, an object this bizarre invited wild speculation the moment it was discovered. Some corners of the internet ran wild with the idea that 3I/Atlas might not be a comet at all, that it could be artificial, engineered, some kind of probe sent by an intelligence we've never encountered. It's easy to see why the theory caught fire. The object's size estimates kept shifting. Its retrograde orbit, moving backward relative to the planets, tilted more than 170 degrees from the plane where Earth and the other worlds circle the Sun, struck some observers as almost too clean, too deliberate. Its trajectory carried it unusually close, in cosmic terms, to both Mars and Jupiter, feeding speculation that its path had been chosen rather than inherited from chance. A few scientists, including some with genuine academic credentials, publicly floated the possibility that this could be a piece of alien technology. And for a little while, the line between hard science and science fiction blurred in public conversation, amplified across every platform where a mystery this size was bound to spread. Webb's data is what pulled that line back into focus. Every chemical signature Webb detected, the carbon dioxide, the methane, the nickel, is exactly the kind of outgassing you'd expect from a natural icy body slowly cooking under sunlight for the first time in billions of years. There's no evidence of engineered materials, no artificial structure, no signal, no propulsion signature. Nothing that breaks the laws of physics or chemistry as we understand them. What Webb found is something arguably more astonishing than an alien spacecraft. Proof that the universe itself is capable of building objects this ancient, this exotic, this well-preserved, using nothing but time, ice, and the cold silence of interstellar space. Nature, it turns out, needed no help writing a story this strange. Still, the mystery hasn't closed completely. It's simply moved to a new question. If 3I/Atlas carries this unusual mix of chemistry, what does that tell us about the region of the galaxy where it was born? Was it forged around a star very different from our Sun? Did it form in a cloud of gas and dust with a completely different chemical balance than the one that built our own planets? Every interstellar visitor we've caught so far, Oumuamua, Borisov, and now 3I/Atlas, has looked different from the last. That inconsistency is itself a clue. It suggests the galaxy isn't manufacturing comets from one single blueprint. It's building them from thousands of different recipes, scattered across billions of years and countless star systems, and every so often, one of those ancient creations drifts close enough for us to catch a glimpse before it disappears again. There's also the question of scale. If 3 interstellar objects have already been detected in less than a decade of serious searching, how many more are out there right now, silently crossing our solar system undetected, too small or too faint for our current telescopes to catch? Astronomers suspect the true number passing through at any given moment could be far higher than anyone previously assumed. Some estimates suggest the solar system could have multiple interstellar visitors drifting through it at any given time, simply too dim, too small, or too far from Earth to trigger a detection. Every one of them would be carrying its own ancient chemistry, its own frozen time capsule from a corner of the galaxy we've never sampled directly. 3I/Atlas may not be a rare exception. It may simply be the first one we managed to study properly, at the right time, with the right instrument pointed in exactly the right direction. And the next generation of survey telescopes, already coming online, are expected to catch interstellar objects far more often than the handful we've found so far, turning what used to be a once-in-a-decade event into something astronomers might expect to see every single year. If that happens, 3I/Atlas won't be remembered as a strange exception. It will be remembered as the moment we learned how to recognize a visitor from another star when one finally showed up. That's what makes this moment feel less like an ending and more like a beginning. Webb didn't just answer whether 3I/Atlas is an asteroid. It confirmed that this object is a genuine interstellar comet, chemically unlike anything born in our solar system, older than our Sun by billions of years, carrying gases and metals in ratios that challenge existing models of how comets form. And it did all of that while the object was already leaving, already accelerating back out toward the blackness between the stars, carrying its 10-billion-year-old secrets with it, forever out of reach. Right now, as you're hearing this, 3I/Atlas is still moving, still outgassing, still visible to the telescopes tracking its final approach through the outer solar system. Soon it will cross beyond the orbit of Jupiter, beyond the reach of any spacecraft we could realistically send, and slip back into interstellar space for good. We will never see it again. No mission will follow it. No future telescope will get a second look. This is it, one pass, one chance, one brief encounter with something that has been traveling since before our world existed. Somewhere in the archives now, in the raw data pulled from Webb spectrometer, sits the closest thing humanity has to a message from the deep past of our galaxy. Not words, not a signal, but chemistry. Carbon, hydrogen, nickel, methane, arranged in ratios that took 10 billion years to write and less than a second of starlight for Webb to read. No spacecraft carried it here. No civilizations sent it. It simply drifted, patient and silent, until physics and timing lined up perfectly enough for a species that didn't exist for most of its journey to look up and understand what it was looking at. So the next time you look up at the night sky, remember this. Somewhere out there, silently crossing the void, an ancient visitor older than the sun just paid us a visit. And thanks to James Webb, for the first time in human history, we got to read its story before it disappeared into the dark forever. And if one interstellar wanderer this strange has already come and gone, the real question isn't whether there are more out there. It's how soon we'll catch the next one.